This is Robbie Nawrocki, and I'm going to be presenting my Lab 5 first order sensors. We'll start off with the actual circuit. Here you can see that one end of this resistor is connected to digital pin 2, which will be providing the voltage output. The other end of the resistor is connected to the positive terminal on the capacitor, and the negative terminal of the capacitor is connected to ground. The voltage of the capacitor will be read on analog 1, and the voltage input will be read on analog 0. Next, we'll take a look at the simulation code in MATLAB. Here we have all the parameters defined for Vn, R, C, and tau. The length of time is then defined, and the voltage across the capacitor is populated in this array here and plotted against time down here. And here's the plots for the 5-volt inputs on top of the results. So if we go ahead and run this, we're going to see that we have the 5-volt step input, the 10 kilo ohm resistor, and the 100 kilo ohm resistor curve in red. The 100 kilo ohm resistor clearly takes much more time to reach the steady state value, but both curves show this sort of increase, and then plateaus off at the 5 volts. Next, we'll be moving on to the Arduino code. So here you can see the various constants, the resistor, which can be changed for 10K or 100K, C, tau, the period, which is going to be 10 times tau, and the interval, which is tau over 50, and both of those are in milliseconds. And the interval is representing the time that it's going to be reading to the serial monitor in between each reading. Here we're starting up the serial monitor and defining the input pins, and then writing to digital pin 2 for 5 seconds at 0 volts to discharge the capacitor. Then the pin 2 is written high for 10 times tau using this for loop here, and the 500 times in the for loop get you up to the 10 tau period, and each time it's going to analog read A0 and A1 and print those to the serial monitor. And then it does the same thing for 0 volts. So if we go and look at the serial monitor real quick, this is for 10 kilo ohm resistor. You'll see in the left column is Vin, and in the right column is VC. Next, we'll move on to the processing code. Here you can see all of the setup, where we're setting up the background and the serial reading port, and creating a table as well to store some values. Then I added text and lines for the oscilloscope, so 5 volts all the way down to 0 volts, and added a legend at the top right for Vn and Vc. Here is where we're actually reading in from the serial monitor, and we've got the two values split by a tab, and then read in to A1 and A2. We multiply each one by 0.5, and we add those to the table and essentially plot them on the screen, as well as print them to the terminal down here. And finally, the table is saved at a designated file location. So we can go ahead and run this. And you'll see this for the 10 kilo ohm resistor again. 5 volts down to 0 volts with all the lines, the legend, and the plot. Finally, we'll move on to the MATLAB analysis code. And here you'll see all of the constants. So R, this can be changed for the 100 kilo ohm by making it 10 to the 4th. Tau is calculated. It reads in from the data file, extracts that data, and multiplies it by 5 over 512 in order to get the voltage. And then it's down here, we're plotting that, and if we were to go ahead and run this, we'd get this output right here. So this is for the 10 kilo ohm resistor, and down here we have the 100 kilo ohm resistor. The key difference is down for the 100 kilo ohm, you've got about 10 seconds where it's applied because of the tau. Here you got a 1 second interval, and both show similar shapes of approaching the steady state value after the step is applied.